Some of this you understand, some of this you don't. You have all seen that. That is simply an equation, yes? You have all seen that. You have seen 2x squared plus 3x plus 1, right? And when you see that as a trinomial, you all know you're going to have to do something with that. Possibly factor it, right? But we found out a couple of days ago that there is math you can do with that even if you can't factor it. I just haven't shown it to you yet, right? Now, the next step is that becomes an equation. Now, in the 9th grade, your equations always had a y and an x, yes? And then in the 10th grade, you were taught that x was an input or it was a dependent variable. Sorry, an independent variable, an IV. And y, you were taught, was an output or a dependent variable, yes? And then at the very, very end of your unit in grade 10, you were taught another way to write your outputs. This, f of x, which tells you that the f is a function. That tells you you're going to do some math to the independent variable to get an output. Everybody remembers this, yes? And in the 10th grade, all your output made nice straight lines, right? Unless you were in pre-dip 10 and then you saw some curves. But we didn't actually do any work with the curves. Yeah? Yeah. So everybody is cool to there. You all know that you can graph math on the Cartesian plane. You have all done it with straight lines only. We are going to graph curves. All right? So vertex is a new word for you. Don't worry, you'll learn it. Vertex is new. X and Y intercepts is old. That's why I'm highlighting it in green. You all know what an X and a Y intercept is. Axis of symmetry, that's a new word. Now, hopefully you all recognize that this green line here that you all are aware of is the exact same thing as that blue line. Right? If I do x times x, I get my x squared, yes? Then if I multiply an a into it, I get my ax squared, don't I? Everybody recognizes this? It's got the same stuff. And this one has the same stuff, right? So you've all seen that. You've all seen solving this equation. That's what we just did, right? If we can get this to x plus 2, x minus 4 equals 0, then you know what x is, don't you? What is x in that case? Bing! Somebody's getting a text. I hope it's the answer to this question. I hope somebody knows the answer to this question because that is on your test tomorrow. Somebody should go back into the videos and watch how to do these because 30 of you cannot tell me the answer to that.
X squared minus 2.
No.
What?
No. Pardon me, Gabriel? Right. X equals negative 2 or positive 4. So all of you should have been able to do that, but you should maybe go back and have a look at things. So you will notice how much green is there, green being things you already know, compared to yellow and blue. Yellow being things you don't know, and blue being things you kind of know if you move around stuff you know. Please notice there is significantly more green and blue, yes? So for the first few lessons of this, there should be no trouble, should there? Because it's all stuff you already know. Now, when we get down to this, that's new. That is new. And applications are new. But until I get down to that fourth thing, there's nothing new, correct? So everybody's going to be cool, right? I hope so. Okay, so before we get going, just over here I want to show you something. Grade 10. In grade 10, we gave you something like this. The f of x equals 2x plus 2. And told you to graph it, right? All of you, of course, remember that that is in slope-intercept form. I start at plus 2, and I have a slope of positive 2. So I go up 2 over 1, and how long does that continue? Forever. So down 2 over 1, and I make that nice straight line. That's grade 10, yeah? Every dot on that line gives you an x and a y, which could go into this equation, yes? Everybody's cool with that? In grade 11, you're going to learn this. F of x equals x squared plus 2x plus 1, and it's going to look like this. Woo! It's going to make a curve. How does it make a curve? X squared, right? Because if I have negative 4 squared, it's positive 16, isn't it? But if I have positive 4 squared, it's positive 16, isn't it? So the only way it can work is if we make a U shape like that. Is everybody cool? All right. Let's do some remembering of things first, please. The first thing, we are going to write the word quadratic because I'm going to use it all the time because that is what this type of function is called. I'm not going to give it any cute pet names. I'm going to call it a quadratic function because that's its name. Just like I call all of you by your names, except when we're having fun and I call Louie Two Blades and things like that. He hasn't told me to shut up yet, but as soon as he does, I will. Yes. Thanks, Louie. You're the best. Quadratics, all right, have an exponent value of 2 on the independent variable. Okay? So it has to be a 2 on the independent variable. Now, most of the time the independent variable is x, right? But is it always x? No. So you actually have to know what an independent variable is. Who remembers what an independent variable is? Oh, wow. All right, let's try. Oh, Damaris, hit me.
It's if you have like two things for your graph, it's the thing that's not reliant. So like time would be an independent
Right.
that keeps going on.
Right. That's a good example. Time is the one I always use. You work a job, you get paid $12 an hour. Two things are changing, yes? The amount of time you spend at your job and the amount you are paid for doing that job, yes? Time is independent. Why? Because time is always moving and it applies to everyone, even if they're not working that day. Everybody understand? So you got to know what that is. It's not necessarily X. It's the thing that doesn't change. Everybody cool? If I jump off a cliff and start falling towards the water at the bottom, what are the two things that are passing? Time and height. Which is independent? Time. Because all of you are on the top of the cliff. In your head saying, awesome, he jumped off the cliff. But somewhere in the back of your mind is saying, he's going to die. Same reason you watch car racing. Because you don't actually care about cars driving in an oval. You're hoping for a crash. Don't tell me you're not. Yes, you are. Nobody watches car racing for... If they did, then when you watch the news that night, they would show all 500 laps. But they don't, do they? What do they show on the news? The crash, right? If you were going to, in a video game, Do they show all hour of you playing a video game, or do they show you getting that headshot?
Headshot.
Right, because people only care about the violence. Okay, so everyone's cool? Everyone can do independent and dependent variables? Okay, so great. So your independent variable is squared. Okay? Now, in grade 10, what color did I do grade 10 before? I did it red, did I not? No. Up here, grade 10. In grade 10, we gave you this. X squared plus 7x plus 12. And what was the instruction that came with that question? Starts with an S, ends with a Y. Simplify. And you, of course, would tell me that that was x plus 3 and x plus 4. Yes? That's grade 10. Everybody cool? Mm-hmm. And grade 10, I warned you if you were in my grade 10 class, I said, grade 10 is the end of where we do stuff that has a real life application all the time. Because in real life, you do not factor trinomials. You just don't. There is no real life application for it. Right? But in grade 11, and if you're in pre-dip 10, we added this. Grade 11 I did in blue. Equals 0. This is now what we call an equation. What makes it an equation? There's two sides with an equal sign. You have a math thing, which is an expression, and that equals another math thing, which is another expression. And it allows you, if you know what you're doing, to find values for the variable. Now, when it's just in red, you can't tell me what x is, can you? If I don't have this blue equals 0, you can't do anything with that. Because you don't know what. If I put something in for x, I could put anything in for x, can't I? As long as it's red. I could put 7 there. And then it would be 110, wouldn't it? Everybody with me? But once I put that 0, it's now an equation, and I can actually find what x is. Yeah? Everybody's good? All right. So, let us move on then, cabbages. We're going to start solving by factorization. Okay? The first one we talk about is the zero product property. That's the one you already know. The zero product property states that A times B equals 0. What do you automatically know about either A or B now? A or B has to be 0, right? Either A or B must equal 0. Does everyone understand that? Yes? Okay. A and B, since they are multiplying together, are what other term do we use for the things that multiply together? If I have two things that multiply together, what are they? A general term for it. The answer is a product. What is the question? Oh, good gravy. Factors. Right, they're factors. Nice. So this says factor 1 times factor 2 must equal 0, yes? No matter what the factor is. Right? So the zero product property says that no matter what this is, if they equal 0, then I've got touch on my screen, so every time I touch it, it's moving. Factor 1, then factor 1 or factor 2 must equal 0. Is everybody following my logic so far? Everybody's cool? All right, so then what we do is we do this. X plus 3 and x plus 4 equals 0. Is that a factor? A single factor? Yes or no? Just looking for a yes or no. Just looking for somebody to have the guts to say yes or no. Is that a single factor? It is. Of course it is. Because the brackets group them together. And if you know what x is, then this is a single number, isn't it? Right? So this is a factor and this is a factor. What does this mean based on our logic? Then factor 1 or factor 2 must equal 0, correct? What is factor 1? X plus 3. That must equal 0. Or, what is factor 2? X plus 4 must equal 0. Can you solve this from your grade 5 algebra? Of course you can. What is x over here? X equals negative 3. What's this over here? X equals negative 4. Is everybody cool to there? Excellent. Now, how does this help us? Watch. That is that, right? Everyone agrees? And that equals 0. Everyone agrees? When x is negative 3, what's negative 3 squared? 9. Plus what's 7 times negative 3? What's 9 minus 21? What's negative 12 plus 12? 0. Everybody see? What's negative 4 squared? 16. What's 7 times negative 4? What is 16 minus 28? 12. Negative 12. What is negative 12 plus 12? 0. Does everyone see how this works? How these questions, because there's a squared, usually will have 2 answers. Is everybody good? Yes? Okay, I'm going to shut up for a few moments while you solve those 3. Actually, no, I'll do those 3 by notes, and I'm going to make you do these 6. A, x squared minus 5x minus 14 equals 0. If you're going to solve that, you're going to solve by factoring, because I told you to factor. I need to multiply to what? Negative 14 and add to negative 5. Right? And what is it? Lucas has already told us. Minus 7 plus 2. X minus 7. X plus 2 equals 0. What do we now know? Listen to me. You already know the answer, but I'm going to write it out. You know that x minus 7 has to equal 0, or x plus 2 has to equal 0. So what are our 2 options? 7 and negative 2. And hopefully you are noticing a shortcut that I am not going to say out loud because I don't want to confuse you. You can find it yourself. B. What's different about B? There's an opening coefficient, yes? And I can't get rid of it from GCF. Have we gone over how to factor these? Yes, I've given you 3 methods. One I personally taught you. One I taught you because Louis remembered it from last year and wanted to see it again because he likes it better. And the third one I didn't teach you at all because I hate it, but a bunch of you from other countries love it, so you're allowed to use it. Okay? I'm going to do my way. I need to multiply to negative 15 and add to 2. What is it? It's 3 and 5, but which is which? Positive 5, negative 3, right? So it is x plus 5, but it's not really plus 5. What is it? 5/3. You hold up a second, Lucas. And then the other one is going to be x minus 2. But it's not really minus 2, is it? 3, sorry, 3. Minus 3, but it's not really 3. What is it? 3 divided by 3. And then I would simplify the fractions to get 1. Is everybody cool to there? Now, when we're factoring, we would bring this 3 to the front, wouldn't we? If we were looking for the factors, right? But are we looking for factors here? Or are we using the factors to find the answer? Which is it? We're using the factors to find the answer because there's a negative or an equal sign here, isn't there? So can I stop right there? Of course I can, because now I have factor times factor, don't I? So either x plus 5/3 has to equal 0, or x minus 1 has to equal 0. And the answers are, of course, negative 5/3 and 1. Why did I know that automatically? That's up to you to figure out that little shortcut, because I don't want to tell you and confuse you. Everybody good? Yeah, yeah? Yeah, yeah, yeah. What's different in C? Anything different from B? Or do we follow the same method? Follow the same method. I know that I got to multiply to 4 and add to 4. What is it? 2 and 2. So it's x plus 2 over 4 and x plus 2 over 4. What can I do there? Simplify to 1/2. Simplify to 1/2. Do I have two factors now? X plus 1/2 and x plus 1/2. Hey, wait a second, they're the same thing. So x has to equal negative 1/2. What's different between there, and there? What's different? You guys have all played the game where you have two pictures and you have to count all the differences. I've given you two pictures now. There's 3. There's that one, and that one. What's different? There's only one. When did you get here? I know that. How did you get there? You are a ninja. Yes, you are. She had to walk behind me, right?
Yeah.
And you all saw her.
Yeah.
Anyway. Did you see her? Well, no, you don't count because you were late too. And you're not a ninja. Whoa. Hey, guys. Whoa. You see how she came in? Yeah. Do that. Okay? Arrive so that I don't know you weren't late. Now, again, I've given you some more time to think while I've been giggling. Rena, thank you. Rena already gave me what the difference is. There's only one x value there, yes? So, obviously, there's times when there might only be one. Everybody cool? All right. So now, you guys, I'm going to shut up. You're going to solve those 6. Go. Those are 6 nice and easy ones. Hey, Mr. Radnine.
How you doing?
I'm great.
You're right.
Go ahead and work these here while you are waiting, or while I am waiting. Is everybody good? Huh? It's only factoring. And there's no number out front, dude. Come on. I'll let you finish that off for a moment, and then please listen. I don't want you doing anything else on that page right now. Stop when you finish the first A, B, C, D, E, F. Everybody good? All right. I'll come back to it in a sec. Please turn your page over to A and B. What is different about A and B in the highlighted box on this one?
They have the number in the front of them.
They are not in this form. Ax squared plus bx plus c equals 0, are they? Can I put this into this? How? Starts with an A, ends with an A, has algebra in the middle of it. Algebra. Excellent. So I want to make this yellow one look like this green one. 8x squared, bring the 10 over, minus 10x, bring the 2 over, negative 5 plus 2 is negative 3 equals 0. Yeah? Now, once you get to there, what do you do with that? If it is possible, you will factor it. Now, Aaron, Danny, and I were having a discussion because Aaron, Danny, and probably Lucas and Gabriel and Isabella all want to do something else with this. And Anna, they all want it. Anna, they all want to do something else with this. What? But it's supposed to be Anna. So it can't be Anna. That's like saying, I'm Mr. Myers, and you would say, I'm Mr. Myers. They're different. I want to say your name properly. When I get to there is something that will allow you to do math with that. What all those other people want to do is what I told you I would be teaching on page 80. That's what you do when this doesn't factor. The reason I'm not showing it to you now is because it does factor. What they want to do is this. B, negative B, or B, I can never remember. Negative B plus or minus the square root of B squared minus 4AC over 2A. They want to do that. Now, you can look at that and say, oh, that makes perfect sense to me. Or you can say, I don't want to use that unless I absolutely have to because that's ugly. You're going to see that very soon. But right now, if it factors, I find factoring to be easier, so you should factor. But I don't care. So you would factor that, and you would get... Stupid touch screen. You would factor that, and you would get, and I'm going to show you just, you need to multiply to negative 24 and add to negative 10. What is it? X plus, not plus. X plus, not plus. It can't be 6 and 4 because this is negative. 6 and 4 would be positive. What must it be? 12 and 2. Plus 2 over 8 and x minus 12 over 8. Then what do you do with those fractions? Simplify to 1/4 and 3/2. Now, x has to equal negative 1/4 or positive 3/2. Everybody cool? Yeah? Then you would do the same thing over here on B. Why is that ugly? It doesn't look like this. Yes? So let's make it look like that. What would you do? Well, this side is x squared plus 10x equals 4x minus 8. Then you would simplify. X squared plus 6x plus 8. Yes? Equals 0. What do you do there? If you can, factor it. X plus 2, x plus 4 equals 0. x has to be -2 and -4. Is everybody cool? All right, now, all you have to do, and this isn't due until Wednesday. Wait, today is not Monday, today is Tuesday. This is not due until Thursday, is I want you to do the 6 questions from page 72 and these 6 questions from 73. Okay? So right now, you have 15 minutes left in class. You can do this, or you can practice for your test tomorrow. Everybody good? Go.